In this video, we will be discussing about probability distribution, right? Suppose I have a coin which is tossed 3 times. Yes. So I have to find probability distribution for of getting number of heads. Yes. So suppose it is concept of random variable x. Suppose let x be a random variable, x be a random variable, and x be a random variable of getting head either 0 times or 1 times or 2 times or 3 times. So first of all, I will define my sample space. So sample space of tossing coin 3 times will be, it will be I have coin, it can either give me head or tail, and I have tossed it 3 times. So my sample space will be 2 to the power 3, that is 8, and I am writing my sample space as head, 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 and tail. This I am extending, tail, tail, and tail. Now head, head, tail. This is the method by which you can write all type of sample space, right? And head, tail, head, tail, head, tail, head, tail. Then now what I needed probability of getting all 3 heads. So it is clearly 1 by 8. Probability of getting 2 heads, right? It is something like this, 2 heads. So it will be 1, 2, 3. So it will be 3 by 8. Probability of getting 1 head only, it will be, right? Probability of getting only 1 head will be 1, 2, and 3. Again 3 by 8. And probability of getting 0 head. 0 head will be 1 by 8 simply. Now see, if I sum this up, I will get 1. So the probability of getting that random variable, I sum up every probability, in the end I will get 1. Right, now the probability distribution will be something like this, and I will write here head 0 times, head 1 time, head 2 time, and head 3 time, and the probabilities are 1 by 8, 3 by 8, 3 by 8, and 1 by 8 respectively, right? So now we will discuss next question, right? Suppose I have a coin, right? Let me see the question. I have a coin which is weighted so that probability of getting a head is 2 by 3 and probability of getting a tail is 1 by 3. Now I have to again make probability distribution of getting number of heads, the same thing again, right? I have to make probability of distribution of getting number of heads. Probability distribution of getting number of heads. That means again probability of getting 0 heads, probability of getting 1 head only, probability of getting 2 head only, and probability of getting 3 heads, 2 heads and 3 heads, right? So the sample space is again the same, and now probability of getting 3 head will be, now this time what I will do, it will be probability of getting a head multiply by probability of getting a head, and this multiply by probability of getting a head, which is 2 by 3 to the power 3, because this is probability of getting head cube, and then probability of getting 2 head, right? I mean HHT will be probability of head multiply probability of head multiply probability of t. So this will be 2 by 3 into 2 by 3 into 1 by 3. And now what I will do? I will find one by one for all these. For getting head, tail, head, then again I will write probability of head multiply probability of tail multiply probability of head, which will be 2 by 3, 1 by 3 into 2 by 3. Right, similar thing, which is 4 by 27. So again I will find this the same for probability of getting head, tail, tail. Then for this probability of getting tail, head, head, and then probability of getting tail, head, tail, and then probability of getting tail, tail, head, probability of getting tail, tail, tail. Right. So why this is happening? Because all these events, right? These are all these events in this question are independent, and all events are independent, and they are also individual events, because here the coin is weighted, coin is biased, so that it has more probability of giving a head rather than a tail. So the events are not dependent, they are independent. That's why to get head at first and then head and then at third time head, these all are independent and we have to multiply them, right? So that's why we are doing this. Now what I will do then, for probability distribution curve, again I will make this 0, 1, 2, 3, and here I will simply, what I will do, for probability of getting no head, it will be simply PTT, right? That will be my answer. For probability of getting one head, what I will do here, I will add all the cases, right? So what I will add, probability of HTT plus probability of THT plus probability of TTH, right? This is what I will do. So this will be 2 by 3, 1 by 3, 1 by 3, 2 by 27. This is also 1 by 3, 1 by 3, 2 by 3. That is 2 by 27. So it will be 2 by 27 plus 2 by 27 plus 2 by 27, 6 by 27. This I will fill here. And then similarly for this, it will be P head, head, tail, P tail, head, head, and then P tail, head, tail. It will be, sorry, head, tail, head. It will be 4 by 27, 4 by 27, 4 by 27. Why? For this 2 by 3, for this 2 by 3, and for this 1 by 3. So it will be eventually 12 by 27, right? So this is how you will make probability distribution for this. Now moving on the next question, I am erasing this. Now next question is yes, next question is find for that biased coin, find probability distribution of getting number of heads getting largest number of successive heads. So what does it mean? Successive mean back to back. So what successive head basically means, for probability of getting 0 head I will have tail, 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 but for probability of getting 1 I will have simply head, tail, head, and then head, tail, tail, sorry, then head, head, tail, no, this is not. What we will do, simply head, tail, tail, and then tail, head, tail, and then tail, tail, head. I can also write this as head, tail, head. So I will have 4. Right, what does successive means? It means back to back. So number of getting one head back to back. Right. So I can get successive head here one time only, and for 2 time it will be, what I will do, head, head, tail, tail, head, head, and head, tail, head. Now for 2 times successively only, what I will remove this, because I want back to back 2 heads, and for this also I want back to back 3 heads. Now I will find probability of all this, so I will add probability of this and this, then I add this and this, and ultimately I will get my probability distribution curve. Right, this you can simply solve. Now next question is, a fair dice tossed for 2 times. I have a dice which is tossed for 2 times. A fair dice which is tossed for 2 times. Now find probability distribution of getting largest number of faces. Probability distribution of getting largest number of faces. So what is happening? Tossed for 2 times, right? And suppose I have A and maximum is 1, and I have event B in which maximum is 2. Similarly, I have C, maximum is 3, and event D maximum is 4. Event T maximum is 5, and event F maximum is 6. Right. So what is happening? When I tossed my dice for first time, I got 1, and then for second time I got 1. For first time I got 1, and for second time I got 2. So my maximum value in which I tossed my dice, I got 2, and then I tossed for first time I got 2, and then I got 1. That means for maximum value in the both cases I got 2. Similarly, for first time I tossed I got 1, and then I tossed I got 3. So the maximum value in which both time I tossed I got is 3. And then also here it is also one more case, both time I got 2, then again I have maximum case of getting 2. Similarly here 3, first time 3, and second time I got 1, so maximum value is 3. First time I got 2, second time I got 3, maximum is 3. First time I got 3, second time I got 2, maximum is 3. And first time I got 3, and then second time I again got 3, so maximum is 3. So sample space is obviously 36. So what will happen? For first time and second time I got 1. My maximum number was 1. So probability of getting maximum number as 1 will be simply 1 by 36. For B it is simply 2 by 36. For C it is probability of getting maximum number as 2 is 2 by 36. Sorry, 3 by 36. Probability of getting maximum number as 3 will be 1, 2, 3, 4, 5. It will be 5 by 36. As you can see, there is a pattern. After every time I am getting 2 more. So it will be similarly, probability of getting maximum number as 4 will be simply 7 by 36. Probability of getting maximum number as 5 will be 9 by 36, and probability of getting maximum number as 6 will be 11 by 36. Right. And accordingly, I will make my probability distribution curve. Right. This is what you will insert in the values. Now, the last question of today's topic is, I am erasing my last question is, sample of 3 items are selected at random for a box containing 12 items. So there is a box in which there are 12 items, and out of which 3 are defective and 9 are non-defective. So let x be a random variable of getting defective item. So I can get 0 defective or 1 defective or 2 defective or all 3 defective. So probability of getting a 0 defective I will find, and then probability of getting 1 defective, then probability of getting 2 defective, and probability of getting all 3 defective. First of all, my sample space will be, I have to select 3 items. So sample space will be C12, 3. This is sample space, and getting 0 defective. That means, yes, that means I have to select 3 items from all non-defective. So this will be C combination of 9 and 3. That means selecting 3 items out of 9 things by combination of 12, 3, and 1 defective. It means I have 1 defective and 2 non-defective. It means C 3, 1 into C 9, 2 by C 12, 3, and 2 defective means C 3, 2 and multiply by C 9, 1 by C 12, 3. Right. And for all 3 defective, I will have C 3, 3 by C 12, 3. So this was all for this. Accordingly, you will make probability distribution curve, and this all one by one you will put those values. So this is all for today.